Oh. Hello everyone. I see people coming. Today we continue our talk about reproducible development environments. Previously, on previous stream, we finished on installing Nixos on my laptop. What we did, small recap, what we did. Previously, we partitioned SSD, generated config file, modified this file to use Flakes, and did actual install on our system, but we omitted a very important step. We didn't configure any user space applications like text editors or messengers or any other stuff, because we already had a home folder with all configurations, and luckily it worked. But today we will try to understand how we can organize our configurations to make it very easy, the same as installation of Nixos, maybe even simpler. How to make it reproducible, for example, if someone will want to use your configuration, or you will want to move this setup to another machine. Our use case will be simple. Imagine we are a developer and we have few different devices, laptop, desktop, Raspberry Pi, some machine in the cloud, and we want to maintain our configuration across all the different devices and have the similar environment everywhere. And the task is pretty tough if you try it to do it, but it's doable. And the simplest solution to use some .files manager, to use git repository, store .files here and link them to your home folder, or using some more advanced .files managers like yet another .files manager. But basically this approach has few downsides which hits you if you want to make your configuration maintainable and reproducible. For example, if you have if you updated package list on one machine, it won't go to another machine, and you need to maintain somewhere this list of packages and check if everything synchronized between those hosts. You also can't do dependency management. For example, if you have vimrc in your .file repository, you can't be sure that Vim exists on the host and it has exact version that you expect. For example, NeoVim version 0.5, for example, or something like that. And also you have some shared data that the same between few different applications. For example, you want to have one color scheme and use it in your window manager or text editor or terminal, and it's relatively hard to share such data between applications. Hello, Rauhai or Rauhal, sorry for pronunciation. Hello, Gleb. I hope you can hear me well. Type something in the chat if you can hear me and the sound is good, or I will try to adjust it. Oh, cool. Hello, Stas. Okay, we described a few problems that people face when they try to manage their configurations. But in case you have only one device, thank you, Stas, only one device and only one set of configuration, and you never update this device and keep this configuration also rarely updated, it's enough to have a Git repository with all your dot files, to have versions of those dot files, and it will work. But if you update, for example, Emacs version, you can't easily roll back. But with the approach we will discuss today, it will be possible to keep not only versions of your configurations, but also to pin versions of the packages that will be used with those configurations. Hello, Elisei. I hope I pronounced your name correctly. Okay, let's go to some examples. Let's switch to my laptop. Boom. And let's see what we have in my repository with all the configurations that I have. And let's start from very beginning. Let's see the structure of this repository. In the root of the repository, I have a flake.nix file. For people who missed my previous stream, I will explain in few words what this file for. Actually, we are talking about NixOS operating system, which is based on Nix package manager and Nix language. And Flakes is a approach to declare dependencies, to declare a function which has some inputs and produce some outputs, and to pin the versions of inputs. And here in flake.nix we provide inputs. It can have different formats. It can be another flake or just a basic Git repository or even a file, I suppose. But in our case, we provide few inputs. It's different branches of Nix packages repository. Stable input will be equal to Nix OS branch of Nix packages repository 2003, and unstable will be following unstable channel, unstable branch of Nix packages. And for people who are not familiar with Nix packages, it's just a big repository which contains definitions of many different packages and also definitions of models for NixOS. And what is NixOS models? Do people familiar here with NixOS models, or I need to explain it in more details? Anyway, I will cover it later, maybe without much details, but it will be covered. Okay, another thing that you can find here is Home Manager, which is, okay, I will explain, sure, which is application written in Nix language, which allows to do the same thing that we do for our configuration of NixOS operating system. But in NixOS configuration, we describe our system, and in Home Manager configuration, we describe our configurations of user space applications and systemd services for user, not system-wide, but user-wide. And it can be used standalone, on the system like macOS or any other GNU Linux distribution, but it can be used as a part of Nixos system. And here today we will be using it as a part of our whole Nixos installation, but theoretically you can use very similar approach to use your to manage your dot files and all the dependencies of those dot files on any, not any, but on other operating system. And a few more inputs here is new Nixos user or Nix user repository, which is similar to Arch user repository but for Nix, and Emacs overlay, which we can use to get the latest version of Emacs. Cool. And now we want to describe a function which takes those inputs and produce as a result operating system and configurations that will go to our home directory. And let's dive in and understand how they will go to our home directory. First of all, let's take a look at what our outputs will be. Here we define a function outputs, we define a key outputs, which is a function which takes inputs and returns the attribute set or dictionary or whatever you call it, just basically data structure which contains keys and values. And we have a key called Nixos configurations, and inside this key we have exe key, which is my laptop hostname, and here you can see a few additional parameters like system, models, and special args. And let's focus on models. Models is what basically Nixos consists of. Nixos has a pretty neat feature which allows you to describe your system with setting different options. Oops, 1 second. And here you can find those options. And for example, you can set kernel models, just a list of kernel models. You provide which kernel models you want, and Nix build will generate a system with those kernel models. You obviously can set a different version of kernel if you want, and so on. You also can configure your system, for example, X server, using those options, and those options actually defined in Nix packages, and they defined using models feature, and we even define one model ourselves, and we'll use it in our configuration a little later. Okay, and here we will have few models declared in our system configuration, and they all will be merged in one configuration. And from this configuration, Nix build will create a system that we will be able to use. Okay, let's go into some file and let's see what is happening here. Let's see my system configuration, and here you can see that it contains some keys and values. For example, here I define some global hotkeys which will work for changing the brightness, and also will be changing the volume and so on. Kernel package, definition of bootloader configuration, which will produce actual grab file, and Also, activation script will install this grab into my laptop if it's necessary, and many other options. And for example, X server configuration, layout, display manager, and so on. And here in display manager, we can see that our session will be just executing of X session file. And we didn't find any configuration related to window manager or any other application in this file because they stored somewhere else. Actually, let's see at my home directory and how it looks. You can see that many files, for example, xsession, xprofile, zeta/env, is symlink to some magic path.zeta/env. And if you look at config.dir alacrity, for example, we will find another symlink here. And all the configuration of user space apps actually will be not the real files, but symlinks to files generated by Home Manager. And Home Manager is kind of extension of Nixos model system, but which can be used even without Nixos. They have the similar idea. And let's just take a look at model example. It will look like that. You have options key, and inside options you declare some other keys, and you declare the type of these keys, maybe default values, descriptions, and other stuff. But later these options can be redefined by user, and it will change the behavior of building script, which will produce the operating system. Basically, that's all that you need to know about models. Maybe a few additional things like when config is generated. In the process of generating configs, if you have values defined in different places, they can be merged if you define the same key, and how it will be merged depend on type of the key and also on priority of definition. But I'm not sure if you want to know these details, and you also can find it in official documentation. Let's take a look at how Home Manager configuration looks like. In the same way, as we define the configuration of our system, we can define the configuration of our user applications. And first application that I defined here was zsh. It's my shell, and here we have a structure of the zsh model that can be found in, for example, documentation on RISE GitLab IO Home Manager options HTML, or in man home configuration.nix. And here we can look for ZSH, and somewhere we will find programs ZSH enable and so on. And let's find the same program ZSH here. Programs ZSH. And we can take a look how model for ZSH looks like. I hope you can see the font on my screen, and it's not too small for your eyes. And here you can see options and types of those options and description for those options. And here in my configuration file, I just define few of them. Obviously, I need to enable ZSH. I want to use a separate dir for configuration files of my ZSH instead of using .zsh rc in my home folder. And also I want a neat feature called after suggestions. When I type something, you can see that it has a gray text which I can use to autocomplete. Also, I will prefer Emacs bindings. Also, I want to store history in separate file. And here you can find an interesting reference to a variable. Here I reference a variable which contains a path to place where I want to store some persistent data for different applications. And here you can see the definition of this path. And it also references another variable, which will be home abcdw, my home directory. Okay, let's go back to our ZSH config. And it can be a small feature in first view, but it's actually really important because you have the shared data between all the applications inside your environment. This can allow you to do, for example, sharing of color scheme between few applications, because you define your color scheme in one place and reference it from configurations for your exact application. Yep, and let's see what we get at the end using this model. After I built operating system and switch to this configuration, I will status the home manager service, which runs only for my user, will activate this configuration and will create all symlinks to Nix source store. And in my home directory, in config dir, config ZSH, we will be able to find a symlink to the Nix store, which contains the configuration. And let's take a look at this configuration. It will be basic ZSH rc file, which generated from this definition, and we can check it. For example, hist file will be following like described here, and let's find aliases. Here we can see those aliases and definition of local variables somewhere here. Okay, let's modify this definition a little. One second. Let's take a look at place where the symlink points. Let's add something to our prompt, and let's build the configuration and switch to it. And now we can see that prompt contains hello string at the beginning. And also, if we take a look at the link, it changed to new place, and it's a pretty cool feature which allows to make a reproducible and also easily rollbackable configurations. I can easily boot and change previous configuration of my whole operating system and all the dot files that was generated during this generation, and switch to it. For example, if I failed the configuration of my window manager and I can't use the system with such configuration, I will be able to pick a different menu item in the grab and to load my previous window manager configuration, actually the whole system configuration, but with a good window manager configuration, and will be able to continue the work. Also, if I share such configuration with another person, which contains not only those source files with definition of configuration, but also contains Flake log file, which has exact versions of all the dependencies. The person who gets this configuration can reproduce the system. And I can use it for myself, but on a different device to reproduce it. And it's cool, but we have few cases that can be hard to cover with such type of configuration. For example, if I already have a file with the configuration of some application and I want to use this file, it can be done by a model called home.file. Here you can define which file you want to bring to your home directory. You just specify a few parameters like source and target. Let's make some example. For example, home file my cool file equal source will be. Let's create some file in my repository. Let's call it echo something important to superfile.txt. Okay, and source will be /superfile.txt, and target will be how target defined here. Options, file, home files. Okay, it will be easier to find it here. Source target, pass target file relative to home. Let's call it our superfile.txt, for example. And now I can rebuild the configuration of my system and configuration of my user space applications. Okay, just a wrong path to file. And I also need to add it to under git control to be able to reference it from Flake. Is not of type a string. Okay, I can do it. Oops. And one more time. And here we can see that super file appeared and it contains something important. And oh no, our super file appeared and it contains something important, and it actually a symlink to some immutable place. Actually, I can't add anything to this file because it's located in Nixstore, and Nixstore is read-only file system. But we can go to this place and see that it contains only one file. Oh. Which is actually the link to another place. Oh, actually it contains a lot of files, as you can see here. It contains the whole configuration of all the programs that I use. And let's take a look at tmux.conf. Boom, my tmux configuration. And let's take a look at xsession. And this xsession configuration generated also from the same place, and also you can find i3 configuration here, which also generated automatically from configuration here. I defined something here, and it converted Nix expression in real i3 configuration and symlinked it to my home directory. Yep, basically you can see the all files that generated from this configuration. But another important feature that I not mentioned yet, that here you can define not only configuration of any applications, but also packages that will be installed only in my profile and will be available only for my user. And here I separated them in few variables, but at the end of the day it just a list of references to packages in Nix packages. Yeah, it's good because I don't pollute any system configurations, and those files is necessary, those programs is necessary only for me, and nobody else will be suffering from having those programs in his path. And another very cool feature that I can reference those programs from configurations. For example, let's take a look at i3 configuration, and here in i3 configuration I have a command for launching Rofi, which my application launcher, and here you can find a very interesting notation which says take Rofi binary from Rofi package, and if you take at my configuration, oh, actually I have Rofi here in programs. Okay, let's take a look at another place. For example, i3log. i3log never defined before. It defined only in this line, and it's explicit reference to the package and to the file inside this package. And that's mean when system build, it will evaluate this package and will create this package in Nixstore. And this string will be converted to the full path of i3log binary. And if we take a look at our i3 configuration, and we'll find a line related to i3log, we can see that here we define hotkey, and it will exec i3log from here, which is absolute path to Nix store, to the place where binary of i3log placed. And actually I can lock my screen, and you can see that I can't open it. Nice, I opened it. And I used hotkey from my window manager, and my window manager executed this application. But if I try to use this application by myself, I won't be able, because it's not in my path. It's available only for the i3log, because it references this binary by the full path. And it's my path not polluted and doesn't contain this directory in the path variable. That is why i3log not available for me as a user, but available for i3 window manager by full path. And it's cool. But the coolest feature that here we defined an explicit dependency between my i3 window manager and i3log utility, and I don't need to worry that on the resulting system that will be generated from this configuration, I will be missing some utilities that used in the configuration but not installed in the system, because when I reference it explicitly, it will be built by Nix build system. Yep, and that means that the setup is pretty robust, and you won't find yourself trying to understand what's wrong with your configuration or what you are missing in your system, because all the dependencies and all the configurations start in one place, and it's really hard to mess something here. Cool. We discussed most interesting features, I suppose. Maybe I forgot something. Let's take a look at my notes. Oops. I think that it won't be too interesting to see how I will change some values here and something happens on my screen, and that I can use the same variable for two different programs. It can be more interesting to see how we can structure our configurations. And let's go to the repository. Let's remove our super file. I don't actually need it. Okay, I don't have tree utility. Actually, I can get it. Temporary tree. Boom. Cool. Most of the place was used by stale configuration. Directory. Here we can see the structure of directories, but it's not very clean yet. That is why let's take a look closely. We have what I think is important for the configuration is separating different concepts. For example, we have configuration for our hardware. We have configuration for a host. For example, we can have 2 Raspberry Pis, and they will serve for different reasons. One of them will contain DNS server, and another one will be containing some HTTP server. And the shared configuration related to the hardware should be somewhere in SRC devices directory, and configuration related to exact host will be in SRC hosts directory. Some models defined in models dir, and maybe we want some profiles. For example, we want a laptop profile, laptop.nix, which will contain the configuration of power saving and Bluetooth and brightness control and something else. Maybe we want a profile for AWS. For example, if we have few instances of cloud virtual machines, and we have a similar configurations for them, we can place it in our AWS profile. And for exact hosts, we will create config files, which will be including those profiles and models, and yep, it should work. Because Nix is pretty decent programming language, we can structure our configuration as we want, as we want to see it, and place different parts which do different things in different place. Nice sentence from Andrew. Okay, we can separate concerns, and we can separate functionality in different places, and just join them in one big file in hosts configuration. Yeah, and it should be easy to manage few different hosts and share a lot of configurations between them. The only thing that will be different, it's list of profiles that will be used for this host, and list of hardware related configurations which defined in devices directory. Okay, any questions to the moment? Anyone still alive? Or everyone went to sleep? I know sometimes I can be a little boring. No questions yet? You're smart. Okay. I think we covered a lot of information already. Thank you, Elisei. We discussed how we can manage configuration for our user space applications. We discussed how we can solve the problem of missing dependencies by directly referencing full path of the binary, or also we discussed how to share the data using variables or something like that. We discussed how we can structure our configuration repository. Yep, and it should be enough to get a very reproducible and flexible configuration system that will install all necessary packages, that will create all necessary configs, and you will be able to roll back in any time to the exact version of your configurations and also packages and start working, even if your some feature broke. Even if your new configuration is broken, you always can roll back and start working with the previous configuration. And also you can share this configuration between your devices or even with your coworkers. About other operating systems, as I said, Home Manager can work on non-NixOS systems, and but you will be restricted with a few things. For example, you won't be able to configure your X server automatically get your X session from your home directory. For example, here I defined a session, and the session file created in my system configuration. But if, for example, you use some other Linux distribution, you won't be able to define such a session, and it won't create a system-wide configuration which will launch your session from the home directory. And in that case, you lose some reproducibility and some nice features, but you still can manage all your user space configurations using Home Manager, but you will need to manually update some system-wide configuration files by your hands, which not very cool, but still doable. Another problem that you won't be able to reference some system configuration, or you won't be able to define some system dependencies, like that you need some audio driver or exact Linux kernel version, some special time zone or driver or something else, or opened firewall ports or anything else that you can define in your system and which can be dependency of your user space applications. But other than that, you are free to use Home Manager and have almost all the benefits of it inside your Linux distro of choice, or even Macintosh or other operating system. Another problem that we have with our a good question, I will answer it a little later. Another problem that we can get with Home Manager is, for example, you generated a configuration file, and during usage of the program, for example, you generated configuration file for Firefox or for VS Code, and during execution of this program, you want to edit this configuration using built-in tools in this application. It won't be possible because your configuration file will be symlinked to read-only Nix store, and that means that you won't be able to configure this application from inside of this application. It may be a problem, but the simple solution for this problem, there are a few solutions for this problem. One of them, you open your application, configure everything you want, and if you never will go back and edit this configuration, or will do it very rarely, you just get this configuration, store in your repository with all other configs, and Home Manager will make this passed to your home directory. Another option, you will create a file which stores another immutable file, and when you edit your configuration using your application, you will be using the immutable file which included or sourced somehow in this configuration, and also it will be possible to store changes that you did during the usage of your application. But you obviously lose the reproducibility of this configuration, because if you did some changes by hands in this file, you won't be able to reproduce those changes. Yep. How can I find an option for the configuration file? Two places where you can find options. For example, one place is man. First of all, you need to know about configuration.nix man page, and here all the options which are system-wide that you can use for defining kernel package, bootloader options, X server sessions, and layouts, and so on. Second main page is home configuration.nix, and here you can find options for your home manager. It looks the same as the whole system configuration, but it defines options for your user space applications. And you can find those options also online, here for Home Manager, on Home Manager side, and here for Nixos. And another place where you can find all those options, you can find those options in the repository, Home Manager repository, models directory, and here you can find the options that you want to know. For example, for i3 window manager, it won't be in programs, it will be somewhere in services, window managers, i3 Sway, and i3 Nix. Yeah, and here you can find all the options, and actually you can find even the source code. And here you can see that it also defines on change key, which a simple bash script which will be executed during activation of your home configuration. That means that, for example, if I change something related to i3 configuration, home.nix, i3 window manager, and workspace back and forth position. For example, I want to use i3 instead of i3 gaps. And I want to be my status bar at the bottom. Now I make switch. It will build my system, my configurations for user space application, and you can see, boom, my bar went to the bottom. And also, if I create a new window, it will have a title bar, which I don't want, and i3 gaps don't have the title bar. Let's go back to our previous configuration, and I didn't touched my keyboard, and you saw that my i3 window manager restarted, reloaded configuration, and it's what is described here. Using i3 message, it sent reload command, and i3 window manager reloaded configuration. Cool. And in the similar way, you can find configuration for Nixos, Nix packages, Nixos directory models, and here you can find any model definition. For example, let's find where X server related models defined. Probably services, X11, xserver.nix. Boom, all the X server related options, and here you can session, start the bus session. Okay, another interesting thing that we won't find anything related to display manager here. Yeah, the definition of display manager options will be in a different file, but here those options are used, and it is an example of how models works for Nixos. You have a lot of actual configurations defined in different places, and after that all those configurations merged in one big dictionary which contains all those configurations, and the rules on which this merge happens depends on the type of the option, and also depends on the priority of the options. Here you can see that it calls make default function with true value, which sets the priority for this value, and if in some other place this option will be redefined, it should have a higher priority, for example make force, which sets priority much higher. Actually the number will be lower but priority will be higher, but it doesn't actually matter. But in case if it finds same options with different values, it will merge it based on some rules, for example priorities. But for example, if you have type lines and you generate a config file from some strings, it can concatenate those strings and so on. Yeah, pretty good to know. Similar mechanisms. Home Manager and Nixos have similar models system. Actually, Home Manager took this model system from Nixos, and similar activation mechanism. In Nixos, it's done by Nixos rebuild switch script, in Home Manager, it's done by systemd daemon or by Nixos application if you use standalone, or by Home Manager application if you use a standalone version of Home Manager. It's just at the end, when everything is built, runs activation scripts which switch symlinks to proper values and do some other activation magic. Ooh, a lot of additional information. Something else that you want to hear from me today? Okay, if there are no other questions, just go to my GitHub repository and take a look of my current configuration. And if you have any questions, you can create issues or write to my email or Telegram, and I will be glad to answer to you. Also, I want to send a link to the chat for my future viewers. https://github.com/abcw reproducible development environment. Ask me any questions. I will be maintaining this repository and improving the structure and documentation of it. In the future, I plan to make it possible to create from a template another flake that will be reference my existing configuration, and you will be able to reuse parts of it and make your own configurations and generate your own system and configuration files for your user space applications, and use the structure that I will create, which will be, I hope, good. Yep, that's all. Place stars in GitHub and likes in YouTube. We'll see you later. Bye.